Okay, hi guys. Let me set up things. Okay, so welcome to our first class for 3272. Oh, I see a question. Um, oh, I lost the question. Okay. Right, so okay, so far what I've posted to my learning is just some course notes and also, oh, just a sec, sorry. Right, so I was just saying that I posted some course notes to my learning, which are just meant to um, kind of keep us on track as to what topics we're doing, and also to be used as a reference for like whatever definitions or theorems. Okay, and then I hope that the course notes will be supplemented by kind of the lectures and the problems and stuff like that. Okay. Um, and then I also posted just a little course outline to give you an idea of some of the details of the course. I don't have dates for any of the course work exams yet, but soon. Okay. And also in my learning, I posted a link to this course. So, I mean, you're here, so you know that. Okay. Right. So let me see. Let me just share the course outline. Oh. So let me try and share. Okay. Here we go. So hopefully I didn't make any errors in this. So I'm gonna try and like for example this class and all the classes and any lectures I record, they'll all be uploaded to YouTube. Probably whenever I post a video, I'll make an announcement in the announcement forum. Yeah, I think that would be the best idea. Let's see. Assignments are going to be 10%. There's going to be 2 exams, each with 20%, and then the rest is the final exam. The exams will all be 12 to 24 hours long, and kind of the length will be so that you can, well, it like probably you should be able to sit down and do it in like 2 hours or something like that for the exams. I just put a list of the topics. Okay, but you can find like more detailed information about the topics and like different textbooks in the course notes. Okay, so let me stop sharing that. I just uploaded those that course outline like about 5 minutes ago. So if you want, you can check it. Oh. Okay. Okay. All right. So if anyone has any questions, otherwise, if not, we'll just we'll kind of start off with just a quick review, and then tonight I'm going to post the first assignment. Will just be like a review assignment, hopefully to get you up to speed. How many assignments am I giving? Well, the first assignment will be due next week, Wednesday. And once everything is okay, I'll just keep on giving them about once a week, except skipping exam weeks. Okay, but that's, if we get into problems, then it'll be less. But I think if we do that, it should have at least 7. But there'll be about like 3 questions each or something like that. Okay. Okay, I guess what I can also do is share with you the course notes to give you an idea. Oh, I see. Oh, is there a WhatsApp group for this course? Do you mean like a WhatsApp group with me as the admin, or maybe you're not asking me? Okay, no problem. Okay, so just to give you an idea of the course notes. So for the course notes, I tried to put in some of the stuff we'll be reviewing, as well as the actual topics in the course. Oh, there's some Some errors. Oh, some stuff I forgot to remove. Oh well. Okay. So this week, kind of my plan is to just do a quick review of things like induction, division algorithm, functions, and stuff like that. And maybe some of the group theory that you would have seen last year. Okay. Okay. So for today, I'll just do something quick to review. But like later, well, by tonight I should have uploaded some like the first assignment, and either today or tomorrow I'll be uploading some lectures. And the reason is I wanna record the lectures where I just present whatever material, and then in class I want to work through problems. Okay, and then hopefully that is okay. Okay. So let me stop sharing this. So the course outline and the notes, you can all get it on My Learning. Okay. Oh yeah, before I switch back to this my sheet of paper, did anyone have any questions about anything? Okay. Okay, here we go. Okay. Okay. So oh. So basically, let's see. The things we need to be familiar with for this class, we have the integers. That would, you start with the integers, and then we have like rationals. The real numbers. Not really going to define them, but we'll just say like 0, 1, -5, 5, or 2, etc. You know. And then we have the complex numbers, which we will define as all the things like a plus bi, where a and b are real, and I squared is this. I squared is -1. Okay. And, you know, all the real numbers are like, any real number is a complex number, any rational number is a real number, and any integer is a rational number, you know? Okay. And we're gonna define new things, you know, starting from these objects. Okay. Okay. And please let me know if the video gets screwed up or something. Okay. So we also need to know about functions. So you have a definition, you know. This notation f from a to b means f is a function, a is the domain, b is the codomain, and what it means is that f assigns like a value, one and only one value to each element of A. Okay. So that means we have a function, you know, and there's a bunch of different ways to define functions. You know, one way I might tell you like that f goes from R to R is defined by I might say it's like x squared, and if x is greater than or equal to 5, I might tell you it's -1 if x is in this range, and then it's like x -1 if x is negative, less than or equal to 0 or something. Oh, it cuts off at the very bottom. Okay. Thank you. Yes. That should be better. Okay, so that is everything that I've written down. Thank you for letting me know about that. I wonder if I can just zoom out. I don't want to mess it up though. Okay, I think that might be a little bit better. Okay. Okay, so we can have functions. You can define them like that, you know, or you can just define like f of x equals sine x for all real numbers x. Or one thing that we'll do a lot is we're going to work with permutations in this course because it's group theory. So let me tell you an example of that. You know, let me set it up here. Say another example. You know, A and B could be the same. And then I'm going to define sigma from A to B. By telling you that, so I'll list everything in the domain. There's only 5 things in the domain, so that's a lot easier than for the real numbers. Okay, and then I just have to tell you, then below each number, I'm going to write what sigma maps that number to. So this sigma is going to map 1 to 1, and then it's going to map 2 to 3, 3 to 4, 4 to 5, and 5 to 2. Okay, so now this tells you, I've told you for each element in the domain, I've told you an element in the codomain, one and only one. Okay. Okay. So, the notation for this, sometimes we might write like sigma of 1 equals 1, sigma of 2 equals 3, sigma of 3 equals 4, sigma of 4 equals 5, sigma of 5 equals 2. And then I've just recorded all this information about sigma into this, into the brackets. Okay. And pretty soon we'll see other ways to write down permutations, but this is like kind of the most straightforward. Okay. So we have functions. If we have 2 functions, we can compose them as long as the domain and codomain like match up, right? So you can define, so if G goes from A to B and F goes from B to C, we can define F, so G, do G first and then do F. That goes from A to C by F of G of X. Well, that's just F of G of X for all X in A. Okay. Okay, so you can compose functions. Okay. For example, this as an example, well, a simple example of that. Define, let's say like tau from 1, 2, 1, 2, 3, 4, 5. By tau of 1 equals 3, tau of 2 equals 5. And then, so to define a function from 1, 2 to 1, 2, 3, 4, 5, I just need to tell you what is tau of 1, what is tau of 2, and I've done that. So I've told you a function, and now the codomain of tau and the domain of sigma match up, so I can compose them. So we can do sigma of tau. Sigma of tau of 1 is just sigma of tau of 1. Tau of 1 is 3, so that's sigma of 3. Sigma of 3 is 4, so sigma of tau of 1 is 4. And similarly, sigma of tau of 2, that's just sigma of tau of 2. That's just sigma of 5. And then we look at the table, that's just 2. Okay, so now sigma of tau is a function that sends 1 to 4 and 2 to 2. Okay. And its composing functions is not so bad. for a lot of groups, well, at least for permutation groups, multiplication is really composition of functions. Okay. So we need an identity function. So let's remind ourselves what that is. The identity. So let's let A be any set. Then we'll define the identity from A to A by the identity of X is just X for all X in A. Okay. And note, so just note, if I have F going from A to B, then I can do F composed with the identity on A. I can do the identity on B composed with F, and those are both equal to F. So the identity function is really like how we think of the identity. Like when I compose with the identity, I get the same thing back. So that's why we call it the identity function. Okay. Okay. And if we have identity functions, well, then we can also have inverses. Okay. So another definition. So F is going to go from, well, F is going to go from B to A and G from A to B. Okay. So if, let's see, so we can do F of G, and F of G is going to go from A to B. So G takes from A to B, and then F goes from B back to A. So F of G is going to go from A to A. And if F of G is the identity on A, then is a right inverse for F. And then if G of F is the identity on B, then G is a left inverse. And if both of these are true, then G is just called the inverse. And we just write G equals F inverse. Okay. Or we could say that G is the two-sided inverse. Okay. Okay. And then, okay, so I want to write down one more fact about functions. Oh, did I miss a bunch of things in the chat? Sorry. No. Okay. Let me turn the page. So Okay, so we have just a quick proposition. So let's say that f goes from a to b as a function. Okay. Oh, wait, before I do this, I have to remind you guys one more thing. Okay. So again, let's take a function. We just have more words. Okay, there's a lot of words in math. Okay, so we have a function. So f is injective if for all x and y and a, f of x equals f of y only when x equals y. Okay, oh, that is, okay, that's better. Okay, that's what injective means, or one-to-one. Same thing. Okay, f is surjective if for all y in B there exists x with f of x equals y. Okay, that's what surjective means. And then bijective means both injective and surjective. Okay. And now we can write down this quick proposition. And of course, being injective and being surjective and having left and right inverses are related. Okay. And having a two-sided inverse is related to being bijective, right? So if f is a function and f is injective if, let me see, I always get this mixed up. So if f has a left inverse and f is surjective if f has a right inverse. Well, if we combine those two things, then f has an inverse if f is bijective. Oh yeah, this is really if and only if. So I'll just put an extra f. Okay. Okay. And then the last thing is that if A and B have the same size and A is finite, then f is injective if and only if f is surjective if and only if f is bijective. Okay. Oops. There we go. Okay. And we want to have all these different notions because sometimes it's easier if we talk about a function being injective. Sometimes it's better to have a left inverse, you know, for example. And then we'll see for groups, you know, F will be injective. That'll be the same as, that'll be equivalent to the kernel of F being trivial, you know, so we'll be able to add to these equivalences depending on like if A and B have additional structure. Okay. Okay. Another thing about functions is that if I have a set living inside A, I can define a new function called the restriction. So let me just write that down. Okay. So if F goes from A to B, and U is sitting inside A, then we can define the restriction, which we write like big line, F restricted to U from U to B. Why? Well, it's just the same definition as the definition of F, you know. But you only let yourself plug in things from U, not all of A. So you get like a different function, but it's really the same function, just with the domain shrunk down. Okay. And that will sometimes be useful. Okay, and oh, I see someone has, oh, sorry about that. There we go. Thank you for telling me. Okay. Okay, I guess now is a good place to stop. I will continue this kind of thing with YouTube videos, and like each topic will get a different video. So depending on which one you need to watch, you can pick and choose, you know. Because this is review, like this will be tested on the first assignment, but it'll just be so that we're all up to speed. Yeah. Okay. So I'm gonna stop there, but if you have any questions, now would be a good time. And oh, also on Friday, I hope that where we like work on some of the problems. Bit of a hiccup there, but I think it's back on. So first of all, I will be uploading the recording of this to YouTube. Okay. And I'll post a link in my e-learning, and then so yeah, and then also the assignment is on what so if you look in like the assignment will just be on this review stuff, so like sets, functions, equivalence relations, induction. Well, of course I can't have one assignment on all those things, but it'll just be like I'll try and put about 10 questions, and then 3 of those questions will be due next Wednesday. Okay, I can write that down in the chat too. Okay. And the topics. Oh, am I? Okay. And the topics will just be on this review stuff, like sets, numbers, functions, that kind of thing. Okay. Any other questions? Okay. Okay. So